Good afternoon, everybody. Today we'll be talking about doses and their productivity. This is actually these slides are from chapter 6 from your text, Purifoy, Lepter, and Schneider. Uh, Dosers are, in general, are from their name. They perform what's called dosing activity. So they are called dosers or bulldozers. Dosing means that they are pushing mainly. So they have a blade, and this blade is pushing by and being pushed by the dozer in order to push soil. Okay, whether pushing soil in whatever direction, this is what also uh, uh, um, controls the name. So if it is an angle, it's called angle dosing. If not, it's a bulldozer, so on. They are mainly used for digging, pushing, dumping, and spreading soil. They are used mainly for short hole excavations within a limit of 100 yards and or maybe 90 meters. Uh, The two main types of doses, according to my mounting classification, are crawler or wheel type mounted doses. So this is a photo of a crawler dozer. You could see this is the track. So it's also called track mounted dozer. It's on tracks, opposing to the wheel dozer, which is actually mounted on wheels, as you could see here. We could understand the major difference between them is mounting and gripping to the soil. So this is why a crawler dozer could work on almost any terrain, while the wheel dozer it's not that case. The crawler dozer could exert a very high force while pushing. However, it's slow, and that is opposing to the wheel dozer, which is faster. However, this is on the account of the force that it could apply. So this was also reflected in terms of the soil that each could excavate. I mean, wheel dozers are typically used for loose materials. However, crawler dozers could handle tight soils. Um, in terms of usage, there is a very wide variety of usage, starting from clearing land, moving rocks, opening up pilot roads, making side hill cuts, moving earth for short distances, as mentioned before, helping loading scrapers, spreading earth fill, clearing construction site, clearing the floor or borrow quarry pits, maintaining whole roads, ditching, loading rocks, rock haulers or crushers, hauling and loading assistance to track shovels, to tractors or shovels, stripping, removing the uppermost layer that we have discussed before. So from because you could see these are very wide variety of usage, this is why it's common to find those. It's common to see them. You will see them a lot in sites. However, because of the difference in usage, the dozer needs to operate in different modes. I mean, if we imagine three-dimensionally speaking, the blade should be able to rotate in the three dimensions. So the first type of rotation is what we call angling. So if you look down there, down, this is the plus 25 and the minus 25 degrees. This is a top view of the blade actually. So this is the rotation, angling is the rotation about the vertical axis. So this procedure is very good in terms of side casting. So when you are doing side hill cuts, backfilling, ditching, and rough grading. Opposing to that is tilting. Tilting is the rotation about the own axis of the dozer itself. So if you imagine this is the axis of the dozer itself, so this is tilting. So it's mainly used when you want to concentrate the force at one point in order to maybe break some hard soil or hard crust. The third one is the rotation about the axis of the blade. So if you see the thing is in light green, this is the side view of the dozer itself. The rectangle is the dozer, and the thing like a crescent, this is the blade. This, it could range from plus or minus 10 degrees. It's mainly used to adjust penetration. So this tipping or pitching is used mainly to adjust the penetration in the soil. Okay, and this, of course, it will be highly dependent on the specified penetration within the soil and the type of soil that you are working in. Dozer blade types there are four main big families for dozer blade types. The first is the typical one, the most typical one, the most common one that you will be seeing is the straight blade. This is the most classical one. Then the angle blade, the universal blade, and the cushion blade. And I need you to look at the differences between the four. The angle blade, you have one dimension larger than the other, one side larger than the other. However, the straight, it's straight. The universal, it's a little bit curved. The cushion, it is of a higher height, however, a smaller width, and it has more like something like stiffness within it. And we're discussing the function of the straight blade. This is the most common thing. It always has a 90 degrees with the machine axis. It's used for digging and dozing. It can be tilted and tipped. It is designed for short to medium distance passes such as backfilling, grading, and spreading fill materials. However, angle blades, it's heavier, longer, and wider than S blades. It can be tilted but could not be tipped because, again, one side is larger than the other. So it already has the angle built in it. So you could not tip it. So it's used for rough grades. It's effective in side casting materials, particularly for backfilling or side hill cuts. On the other hand, the universal blade, the U blade, it's heavier and bigger than the S blade. You'll notice that each one is denoted by the first character. So straight is S, universal is U, cushion is C, angle is A. Okay, it can be tilted and tipped, and it can move large volume of material over long distances because it could accumulate a lot of material. Because now it has this curvature. It's more like an arc shape. So this curvature maintains it to prevent any losses from the sides. Now you will not have any losses from the sides. So it should not be used for high penetration because you could not have high tipping. You could have tipping but could not, or pitching, but you could not have high pitching in it due to this curvature. So you could not have it for high penetration. So this is why it's mainly used for loose or non-cohesive materials, because typically stiff clay or something like that, it needs to exert a force using the pitching rotation. But now you could not do this, or you will do this with a limitation. Could not easily do it. So it's mainly used for loose materials. However, the issue of the capacity will make a big difference in terms of being capable of moving the large volume for larger distances. Then the cushion blade, from the name and from the picture you could see, it is stiffer because it is reinforced to absorb shock, and it's the width is less, so it could concentrate the force that it is applying. So it's mainly used to load the scrapers. I mean, to push the soil into scrapers, not pushing scrapers actually, like Matt mentioned. It's loading the scraper, it's pushing the soil into the scraper. And we discussed this process when discussing scrapers. However, because you need to concentrate this force, you need this thing to be reinforced by these stiffness that you could see, the vertical members, and these vertical members. And you need it to be shorter than the S blade, which is typical. So that takes us to the dozer operation types. I mean, you have one of three modes of operation of dozers. Either what's called straight shuttle excavation, or side hill excavation, or backfill excavation. The straight shuttle excavation is something very simple. You dig and push. This is the first step. Then and of course this depends on the distance. This depends on the distance, because while digging you are pushing, you are hauling, then you shift gears. This is the fixed component of time, and return back while empty, then shift gears again and start the cycle again. So here you are having 4 steps within this cycle. However, side hill excavation is different. Side hill excavation, you are dumping on the side hill. So you're not digging then going to travel and dumping. No. You are excavating and dumping at the same time, or you are pushing and dumping at the same time. So you dig and push, then you swing and dump, then you shift gears, you then back up and swing and shift gears again. So you could notice that all of these cycle times, by the way, these times they are not a holy book. These are average times. So you could see that this average of 0.8 minutes, this is a fixed cycle time. It is the backfill excavation. However, there is one step difference here. You push and dump, you shift gear, you swing and dump, and then you shift gear again. This is mainly while dumping soil into a trench, or while backfilling a trench. Okay, so here the cycle time is 0.64 minutes, and we will continue in the next video, inshallah.